From my last video, we know that our home routers are also firewalls, and we can harness their power using OpenWRT. We also know that a PC can be a firewall, not just with OpenWRT, but also with OPNsense. Let's now take a look at OPNsense and learn how it can protect our network with firewall rules. Welcome back to Dev Odyssey, a developer's journey through IT, where I cover tutorials and reviews of IT tools and technologies. I'm your host, Oris, and in this episode, we're making firewall rules in OPNsense. I already covered the definition, background information, and benefits of firewall rules in my OpenWRT firewall rules video. This definition does not change between firewall technologies, so feel free to watch that video. I've also covered the history of OPNsense and BSD-based firewalls in my Installing OPNsense video, so check that video out if you want more background information. Let's move forward with some specifics of how OPNsense does firewall rules. Just as with OpenWRT, OPNsense firewall rules are port-based. Protocol traffic is tied to port numbers. However, just as I mentioned in my OpenWRT firewall video, there are new firewall technologies, like Next Generation Firewalls, that can inspect Layer 7 application traffic and use that as the basis of firewall rules. This tends to fall in line with our thinking of how we want to create firewall policy. We want to control certain types of traffic, not just their associated ports. While there is no way to achieve this functionality in OpenWRT that I know of, OPNsense does have a plugin developed by Sunny Valley for creating Layer 7 application-based firewall rules. While we won't get into that in this video, I'll share a link below so you can learn more about them. If you'd like to see me create Layer 7-based firewall rules, drop me a comment below. To demonstrate firewall rules in OPNsense, I'll be using the following. For hardware, I'll be using my OPNsense Mini PC appliance. As you may have noticed, I did have another appliance PC, but I accidentally fried it when I was messing with the jumpers, trying to get the Mini PCIe slot to work with OpenWRT and the cellular modem. It's a good reminder to not mess with board pins if you don't know what they do. For software, I'll be using the latest version of OPNsense 23.1. Now that we're done with the chit-chat, let's get into the demo. Firewalls in OPNsense are based off a software package called BPF, or Berkeley Packet Filter. This was one of the original firewall softwares written, so it has a long-standing history and strong reputation as a firewall software, along with its successor, eBPF, where E means extended, and it's been ported to Linux, so it can use the same power that BSD machines have. First, let's log in and navigate to Firewall on the left-hand side. You'll see in the dropdown, we have multiple different firewall options available. In this video, we'll touch on aliases, NAT, and go into detail with rules. Click the aliases section. Here, we can define an IP or set of IPs under an alias, making it easier for us to use in our firewall rules. Let's create an alias. At the bottom right-hand corner, click the plus button. We'll make the alias for all private IPs, or commonly known as RFC 1918 IPs, named after the request for comments that define them. For enabled, leave that checked. For name, let's call it RFC 1918. For type, click the dropdown and change it to networks. If you wanted to specify individual host IPs, you can do that as well, and leave it as hosts. For categories, leave this as blank. This lets you add metadata to your aliases for easier organization. For content, we'll put the following networks: 192.168.0.0/16, 10.0.0.0/8, and 172.16.0.0/12. These are all the available private IPs we can use in our home networks. For statistics, leave this unchecked. If you want stats on this alias, such as how often it gets used, then feel free to check it off. For description, type all private IPs RFC 1918. Once done, click Save at the bottom right. Then click Apply. Congrats! You've created your first alias to use in Firewall Rules. Now that we've done that, let's move over to the NAT section for a brief description. Click NAT. Here, there are more options in the dropdown, including port forward, one-to-one, outbound, and NAT v6. We already know about port forwarding, so let's learn about outbound. In the outbound section, we have a few radio buttons for different modes: automatic, manual, hybrid, and disable outbound NAT. Outbound NAT is effectively the same thing as masquerading, as we saw in my OpenWRT firewall video. For any IP leaving local networks, such as LAN, and going through the WAN interface, the source IP is changed to that of the WAN interface IP. This works like any other NAT we use daily. Here, we simply have more options on how we want to configure NAT, and even write some of our own rules. Something like this is useful when creating site-to-site VPNs or using nested OPNsense firewalls with a single NAT. I have done both of these setups, and if you want to see how it's done, drop me a comment. Let's now move into the star of the show, Firewall Rules. Click Rules in the dropdown, and then click LAN. In here, the first thing you may notice is that there are no firewall rules. That's actually not true. There are floating and auto-generated rules that are necessary so that you can get an IP address via DHCP and so that you can actually log in to the firewall. Let's take a quick look at these. Under the plus button on the right-hand side, you'll see the number 9 with a down chevron. Click that. Now you see all the automatic rules created here. Notably, they are what I just mentioned: IPv4 and IPv6 rules for DHCP, and the anti-lockout rules so that you can't access the firewall web UI. Let's hide these for now and get to making our first firewall rule: pass ICMP traffic to all private networks. Click the plus button to the right. In this view, we have lots of options for creating a firewall rule, which I will cover each as we reach them. For action, this defines what we want to do with the matching traffic. Our options are pass, block, and reject. When comparing to OpenWRT, pass is like accept, block is like drop, and reject, they're both the same. Let's leave this as pass. Since the default action is to block or drop traffic, the rules in this demonstration will be pass or allow rules. For disabled, this makes the rule disabled after we finish creating it. Leave this unchecked. For quick, this defines if other rules should continue to be processed after this one. By default, the last matching rule for received traffic is applied to the traffic. Using quick disables this, meaning the first matching rule is applied to the traffic. Leave apply the action immediately on match checked off. For interface, this defines what interface you want to specify for the rule. Leave it as LAN. For direction, this defines what traffic direction you want the rule to apply to, such as in or out. Leave it as in. For TCP/IP version, this defines if you want the rule to apply to IPv4, IPv6, or both types of traffic. Leave as IPv4. For protocol, this defines what traffic protocol you want the rule to apply to. Choose ICMP from the dropdown. For ICMP type, This defines the ICMP traffic you want the rule to apply to. Leave this as any. For source invert, this defines if you want the rule to apply to the traffic source IP or the opposite of the source specified. Leave it as unchecked. For source, this defines what IP or alias you want the traffic to apply to. Leave as any. For source advanced, this gives you more advanced features like specifying source port, which is not commonly used. Skip this. For destination invert, this defines if you want the rule to apply to the traffic's destination IP or opposite of the destination IP specified. This is useful when you want public IP addresses or non-RFC 1918 IPs. Leave it unchecked. For destination, this defines the destination IP or alias you want this traffic to apply to. Specify the RFC 1918 alias we made earlier. For destination port range, this specifies what destination port range to match the traffic on. This doesn't apply with ICMP since layer 3 traffic is portless. Leave it as is. For log, this will log the traffic that matches this rule. Unlike OpenWRT, this applies to all actions, including pass allow actions. Check off log packets that are handled by this rule. For category, this allows you to add category tags to the rule for easier rule organization, especially when multiple rules have the same category. Leave it as blank. For description, this is a place to provide contextual information to the rule. Set it as pass ICMP RFC 1918 private IPs. Under Advanced Features, leave No XML RPC Sync unchecked. This is regarding an advanced networking feature that doesn't apply to basic firewall rules. For Schedule, this lets you schedule rules to be enabled or disabled at certain specified times of the day on a recurring basis or one-time basis. Leave it as none. For Gateway, this defines what gateway you want the traffic to use for rules that match the above criteria. Leave it as default, which then uses the system routing table. For advanced options, we'll ignore this, as this gets more in-depth than necessary. With all that complete, click Save. Let's make one more rule. Pass SSH to all private networks. Click the plus button once more. For disabled, leave this unchecked. For quick, leave it checked off. For interface, leave it as LAN. For direction, leave it as in. For TCP IP version, leave it as IPv4. For protocol, choose TCP from the dropdown. For source invert, leave it unchecked. For source, leave it as any. Skip source advanced. For destination invert, leave it unchecked. For destination, specify the RFC 1918 alias we made earlier. For destination port range, select SSH. For log, check it off. For category, leave it as blank. For description, set it as pass SSH to RFC 1918 private IPs. Click Save when you're done. For the new rules to take effect, we need to click Apply Changes button at the top right-hand corner. Let's do that now. Now that we have our two new rules, let's go ahead and verify they work with some simple tests. Before we test, let's enable SSH access so we can get some good validation that the rule is working. To do so, navigate to System, Settings, then Administration on the left. In here, scroll to the Secure Shell section. Check off Enable Secure Shell, Permit Root User Login, and Permit Password Login. We're using root for testing purposes, but in any production deployment, you'd want to log in as other users you created with SSH keys, as that is more secure. Scroll to the bottom and click Save. Now to verify our rules, we want to see when our rules are being hit. To see this, we can look at the Log Live view. Under Firewall, click Log Files, then Live View. Here, we can see all the rules that have logging enabled. Let's set some filters so we can easily see when our rules are hit. First, click the plus button to add the existing filter, Action Contains Pass. Next, add the filter label Contains Pass ICMP using the drop-downs and input box. Click the plus when you're done. Now, when our rule is hit, it should be the only rule to show up in our search and confirm that our rule is working. In the terminal, let's ping the OPNsense interface 192.168.1.1. Let's go back to OPNsense and check the live view. As you should notice, we have entries for our rule showing up, indicating that our rule is being hit and working as expected. Let's change the filter to check for SSH traffic. To do so, click the label Contains Pass ICMP and change it to Pass SSH and click the plus symbol. Once more in the terminal, let's run SSH root at 192.168.1.1. Well, clearly, since I'm getting a response, this means it's working. Let's check the live view anyway. Again, you'll notice the entries for this rule showing up, giving us another indication that the rule is working. I will have to say, during my testing and making this video, I actually noticed that the anti-lockout rule does cover port 22. So initially, when I did this, I didn't actually see my rule show up in the log filter. That's because the anti-lockout rule covered it. So to test this out, I disabled the anti-lockout rule administration features. I don't recommend that unless you've covered your bases for making sure you have access to the firewall and don't accidentally lock yourself out. And with that, we've covered creating basic firewall rules in OPNsense. As we just saw, there are plenty of powerful options when configuring firewall rules in OPNsense. However, what makes OPNsense more powerful is knowing what rules to write to allow your home network to function while also blocking attackers. I'm very familiar with this process, as I first learned to set up home networks with common port-based firewall rules for TCP and UDP traffic using OPNsense. I learned this from a great book by No Starch Press called The Book of PF. So if you want to learn more about those and how to do it, let me know in the comments below, and I'll also drop a link to the book. To wrap it up, there are a few differences between OpenWRT and OPNsense I'd like to highlight. OPNsense doesn't have the concept of zones, which I think simplifies firewall rules, but I do appreciate the organization and power zones give you. Second, OPNsense lets you create aliases for common used IP addresses, making your rules easier to understand when reading. Lastly, my most notable difference is by default, all interface traffic is dropped, besides the anti-lockout rule, unless a rule is specified to accept or allow it. It's these differences, along with its polished web UI, its management features, and live log view that make it my preferred firewall operating system. Now, if OPNsense had better hardware support, then it would be perfect for me. But this is where OpenWRT and Linux will always outshine OPNsense and Unix-based OSs. Thanks for following me in my journey. I really appreciate it. If you got some value out of this video, go ahead and give it a thumbs up. And if you like this type of content, and other content around IT technologies, networking, security, and more, go ahead and subscribe to my channel. Click that bell for notifications so you don't miss the next video. How would you set up your firewall rules? What pass rules would you create? What traffic would you block? Would you use application-based rules? Drop me a comment below and we could discuss it. Thanks again, and I'll see you in the next video.